Good morning, everyone. Welcome. Thank you. Welcome to the final day of Build Conference 2012. Since we launched Windows Phone back in 2010, one of the most common requests we've had from developers such as yourselves is to bring native code to the platform. And as you heard in June at our event, and as you've been hearing this week at Build, we've done that in a big way in Windows Phone 8. So my name is Peter Tor. I'm a program manager on the developer platform here at the Windows Phone team. And over the next hour or so, I will be talking to you about how you can use C++ in your Windows Phone applications. And hello, everyone on the webcast, too. So the agenda for today, we'll talk about three things. Firstly is C++ support in Windows Phone 8. Next is when and why you might use that. And thirdly is an introduction to the Windows Phone runtime. Now, there'll be about 30 minutes of demos in this talk, so it's less about slides and more about actual Visual Studio code. So hopefully you'll enjoy that. But I want to start off by just saying kind of welcome back to C++. Over the past decade or so, there's been a very big focus on managed code, C#, VB, and so on. And last year at Build, they talked about the renaissance of C++, and how modern C++ is really coming back, especially with the Windows Store platform and now the Windows Phone platform. So welcome back to C++. Now, how many people recognize this book? No one? OK. How many people recognize this book? One person. OK. Usually everyone says they recognize the one on the left. Basically, the point of this slide is that a lot has changed since I was programming C on the Commodore Amiga a long time ago, and today, where you can use C++ 11 and a lot of modern concepts in your programming on something like the Microsoft Surface. And so today, not only will we talk a little bit about using C++ in your Windows Phone applications, we'll also talk a little bit about some of those new C++ features that you can use that might not be familiar to you if you haven't touched C++ in a while. So what does C++ support look like in Windows Phone 8? Well, it's Visual Studio 2012, same as Windows 8, same compiler, same tool, same libraries, and it does have a lot of new C++ 11 features, as I mentioned. So we're not just bringing a subset of C++, we're not just bringing a small amount of C++, we're really bringing you full Visual C++ 2012, same as Windows 8. So this is the real thing. And now the purpose of this slide is not for you to read all the words and to see every feature that's in Visual C++ 2012. It's more just a kind of bamboozle everybody with keywords type slide, just to say that there is a lot of new stuff in Visual Studio 2012. So with that, I want to start with a quick demo of some of the key features of C++ in Windows Phone 8. So I'm going to do a quick view of the new project dialog and then a quick look at the default C++ project template. I will not go into depth about this template. If you want to know more about DirectX programming and writing DirectX games on Windows Phone, Sam George has an excellent talk that you should go watch online. But I will just touch on some of the basics here. So here we are in Visual Studio 2012. And if I go up to the File menu, New, Project, you can see here we have Visual C++ as a supported language. And we have a bunch of templates here. First, we have Direct3D with XAML app. That lets you actually mix XAML-based controls and UI with Direct3D-based UI. We have a native-only app, which is pure DirectX, and that's the one we'll be looking at. We have a Windows runtime component, and we'll be talking about those a little bit later in this talk. And we have a dynamic link library and a static library. So if you're a seasoned Windows developer, this should look familiar to you, right? You can write libs, you can write DLLs, and you can write executables. So I'm going to go ahead and create a Direct3D app native only. It will go ahead and create that project for us. And I'm going to build it in the background. But I just want to give you a quick tour of some of the things here. Again, it's not going into depth. You should see Sam's talk if you want depth. But you can see here that yes, this is C++, right? It's not It's not any other language. It is real C++. You might notice some of these hats. I'll get to them later on, don't worry. But we have real C++ code here. We also have real shaders. Right? With Windows Phone 8 and Direct3D, you also get real shaders. So this is a high-level shader language. Right? So just the kind of thing you would expect writing a Direct3D app on Windows, you can do the same on the phone now. Another thing I want to show you is if I pop into the manifest of the application, which describes the application, if any of you have built Windows Phone apps in the past, you may know that you end up building a managed DLL that gets hosted inside a host process that we own. Right? And I said that this isn't watered down C++ in Windows Phone. This is real C++. So you can see that we are actually building executables now. So it's not a host process that we run that you get to put some stuff into. Right? This is your executable, your process. And then the last thing I kind of want to show just about the project in Visual Studio is if I right-click here and go Properties, you can see we have all of the C++ properties here. Here's that wonderful C++ command line that I don't think anybody understands. We have the linker, right? All the linker options. Right? Everything is here. Right? This is real C++ running on Windows Phone. So I'll shut that down, and I'll just run the app for you just so you can actually see it. It's just going to be a cube spinning. So this is a Direct3D app running, shader code running on Windows Phone. So that's all we'll look at right now for the kind of just orientating ourselves inside Visual Studio for C++. So if you already know how to use it, it just works the same way. So when and why should you use C++? Now, some of you might say always. But that's not necessarily the case for developers who already have a lot of experience or code with C# or VB. So the good news about C++ in Windows Phone is that all apps can use it. Right? You can have Direct3D-based apps, like the one I just showed you with the cube, that are pure native code. And you can have XAML apps that are a mixture of C# or VB and XAML and native code, either for computation or for Direct3D inside of your XAML app. But the key thing is that not all apps and not all developers need to write C++ code. What I mean by that is if you're an established C# or VB developer and you are happy doing that and you have apps that have the features that you want and the performance that you want, there's no need for you to go and throw that out and start writing C++. You can if you want to, but there's no need for you to replace your existing C# or VB code with C++. So if you don't need to do it, if you already have existing code, then what are the reasons why you might use C++ in a Windows Phone app? So who thinks performance is the #1 reason we might use C++ in our app? OK, a few hands go up. That's not the way we see it. It does give you good performance in certain cases, but that's not the way we see it. Who thinks portability is the #1 reason we have C++ in Windows Phone? I see a few hands. OK, well, you guys were right. That's the way we looked at it when we built this into Windows Phone 8 was portability across Windows, iOS, Android, and Windows Phone was our #1 goal for C++. Reusability of common libraries was also a good goal for us. And performance does make a lot of difference for certain things like games and so on. But again, if you're a C# developer and you have existing applications running on the phone, don't automatically assume that converting some of your code to C++ will make it faster. Right? There are some overheads involved with native to managed interop, and the managed code is actually very, very fast now, especially on our new hardware with dual core, with our compile in the cloud technology. There's no real reason to move your managed code to C++ if it's already working great for you. Right? You can do it, but we're not recommending people just go out and do it just for the fun of it. Well, you can do it for fun. So now I'll talk a little bit and show a demo of some reuse of C++ code in Windows Phone 8. And in this particular demo, I was having problems earlier this morning with my Hyper-V network. So if it doesn't work, I apologize. But let's just see what's going to happen. So what I have here actually is not Visual Studio 2012. This is Microsoft Developer Studio back from 1994. And it's running Visual C++ 4.2. Does anybody here use that? Have? Yes? No, you wouldn't use it now. But some of you have used it. Good, good. So what I have here is, let me just run it, is an application that is a stock analysis application. And Dev Studio is not responding. We'll give it a second to see if it builds. But essentially, it's a command line program that lets me type in stock tickers, like MSFT, and it comes back and gives me recommendations whether I should buy or sell or hold. And it looks like, I said I was having trouble with Hyper-V. Let me give this one more chance. I will end the process and start it again. There's this thing called the Start menu as well. You may have heard of it. So there's the Developer Studio boot screen. Let's try one more time to open that project. I suspect Hyper-V networking has messed up again because it's trying to load files off the local machine. It's not responding. OK, anyway, what you would have seen is a console app. I type in a stock. It gives me back a recommendation. And then what I want to show you here in modern Visual C++ is the same code. You may have seen this on the screen before the screen died. This is very, very simple C code. The purpose of this particular demo is not to show all the bells and whistles of C++ and all the advanced features. It's really just the concept of taking code that you wrote a long, long time ago and moving that investment forward and having it run on the phone. Now, let's just see if this will work. I'll try one more time. One more time. OK, I'll give up on that. So it used to be a console app, but now I've brought it into the modern world, running on Windows Phone. And I have a nice modern UI. And I'm using exactly the same code. So I can do things like have the text MSFT here, and click Get Recommendation. And it will call that same library function.
Recommendation for Microsoft is buy.
And it will actually use some of our new modern technology like speech to give us a great modern experience. And I can also talk to it, too. So I can say, Apple.
Heard you say Apple.
And then I can get a recommendation for Apple.
Recommendation for Apple is hold.
OK. I'm not a financial analyst. Don't take this as financial advice. Talk to your lawyer, etc. So you can see that I have a modern, new application using the same code I used back in the demo you didn't see. But the key thing is that this code really is actually exactly the same file, and it was being shared with my Hyper-V version of the application. And what would happen if this was working was that I would go back to the virtual machine running the old Visual Studio with the old code. I would update that file, and you would see that the console app would be updated. And it would also automatically update my modern app, my app running in the Windows Phone, because it was exactly the same source code running in both places. Right. Again, the purpose was not to see the most complex code, but just to show you that old investments you have in code can be brought forward to the phone. And clearly, there's a lot of magic in how I got from this old C code into a speaking, listening phone application. And we'll get to that magic in the next demo. So I apologize for this one not working exactly as it was supposed to. But we will move on. So next, I want to give you a very brief introduction to the Windows Phone runtime. You've probably heard a lot about the Windows runtime, build last year and build this year. And we have a version of that on the phone we call the Windows Phone runtime. I will probably just refer to it as the Windows runtime or WinRT for the purpose of this talk. But it's essentially the same idea and the same concepts that are on desktop Windows are now on Windows Phone. So what is the Windows runtime, in case you've missed everything we've said about it? It's really two things. It's a set of infrastructure and a set of APIs. And the infrastructure is kind of like the old COM infrastructure. It does things like plumbing of type activation and memory management and so on. It has a set of core types, like strings and enumerables and vectors and so on. And it has a common programming model around objects, methods, events, exceptions, and so on. And there's also, of course, WinRT APIs. There's features that the phone has we expose, like speech or networking. There's libraries that you write, or that you license, or that you get off the web. And these APIs are projected naturally to the target language, whether that's C# and VB, or C++ on the phone, or on desktop Windows also JavaScript. But the phone does not support JavaScript right now. So that's what it is. When do you use the Windows runtime? Well, three places. Firstly, if you're calling Windows runtime APIs, you're obviously using it. If you're doing native and managed interop on the phone, you use Windows runtime. And lastly, if you're doing a direct 3D-based game, like the one we showed with the spinning cube, that's also bootstrapped with a Windows runtime application model. But because these APIs are projected into the language of your choice naturally, these things kind of just fade off into the background. Right? After a while, you don't realize you're using a WinRT API. You're just using an API. And we'll see that in one of the demos in a little bit. So you use the Windows runtime all the time, writing Windows Phone applications and Windows Store applications, even if you don't actually know it. So I'll move to the next demo, where we will talk about calling some of these Windows runtime APIs from C#, and you'll see just how transparent it is. We'll then create a component in C++ and use it from C#. This will be that financial analysis app again, where that native C code I had is now working in a Windows Phone app. And then we'll look at solving one of the performance issues in that old code by moving it to the awaitable asynchronous model. So let's switch to Visual Studio again. OK. So now here we have in Visual Studio, let's go full screen, we have the event handler that gets called when I click on the, the listening to me part of the app. This is the code that gets called when I click on the microphone and it starts listening to me. Now, who can see where the WinRT code is in this particular bit of code I've highlighted? Right. Can anyone shout out where the WinRT is? No. Right. I said it was very natural. It's projected very naturally. This speech recognizer UI object is actually a Windows Phone runtime type. Right. But you would never know that by looking at this sample code. Right. I just knew it up like it was any managed object, and then I go ahead and use it like a managed object. I can call methods on it, and I can pass in C# strings. This is actually a managed dictionary, so I can pass managed dictionaries into it. I can set properties, and it follows the async pattern, so I can await it and use some of that cool new asynchronous programming in C#. Right. So the Windows runtime usage in managed code is really transparent to you. And unlike in previous versions of Windows Phone in Visual Studio, where we didn't automatically reference every assembly for you, sometimes you had to go add reference and find an assembly to use. In Visual Studio 2012, we automatically reference everything for you. So all you need to do is add the using declaration at the top here, using windows.phone.speech.recognition and synthesis, and you're good to go. And that's actually another tip. If it begins with Windows dot something, it's a Windows runtime API. If it begins with system dot or Microsoft dot, then it's a managed API. So that's really the only way you ever know that you're dealing with Windows runtime. So that's what happens when I click the microphone. And so using the APIs is very transparent. This is the code that gets called when I click on the Get Recommendation button. And again, who can point out the Windows runtime code here? It's the stock analysis. Right? That's the code that I'm going to show you that wraps that old native code into a Windows runtime wrapper callable by C#. So again, I just knew it up. I call a method on it. Completely transparent to me as a managed developer. When I get the result, I simply put it in a text box, And then I use another Windows Runtime API, this is the speech synthesizer, to speak out that text recommendation is buy or hold. Okay, so using Windows Runtime components, both provided by Microsoft and written by you, is incredibly easy in C#. So let's look at what it takes to write this stock analysis object in C++. So we'll start off looking at the header file. And this is a pretty standard C++ header file. We are using some of those newer C++ features. So again, if you haven't touched C++ in a while, some of these things may be new. We have a namespace. So we can put our names inside of a namespace so they don't pollute or collide with other people's names. We're using a couple of namespaces. This is Windows Foundation, which is part of Windows Runtime, and Platform is also part of Windows Runtime. There is a method here I will be using internally to convert a platform string to a character array. We'll look at that in detail a little bit later. I have an enum class. This is a new C++ feature that lets you have enum members like buy, sell, and hold that are actually scoped to the stock recommendation name, so they're not polluting the global namespace. And then here I have a C++ class with a single method in it called getRecommendation. And the thing that makes this a Windows Runtime class versus just an ordinary C++ class is that it has that keyword ref in it, meaning it's a reference-counted Windows Runtime class. And it has to be sealed as well because of some of the rules of WinRT. But basically, you just write C++ classes, and you put ref in front of it, and then anything that's in your public surface area of that class projects out to the different languages as part of a Windows Runtime object. And there are some limitations on the types you can expose through Windows Runtime. Strings and numbers and platform, things in the platform and Windows Foundation namespaces. But not all C++ types can be projected out this way. We'll see in a moment, for example, that I wouldn't be able to put, say, a std vector out of my Windows Runtime component. I'd need to wrap that in a WinRT vector type. So the header file for my stock analysis WinRT class should look very familiar to anybody that's done C++. So let's switch over and look at the implementation. So here's my getRecommendation function. And we'll see that it takes a string hat stock symbol. And I promised you earlier I would talk a bit about the hats. Now, if anyone here has done managed C++ in the past, you might be thinking to yourself, that Peter guy, he's been lying to me because this hat means managed C++, and managed C++ means it's not really native. It means it's running on the CLR. Well, that's not true. We're using the same syntax as managed C++ with the hat to mean a ref-counted WinRT object. But this is real, honest-to-goodness native C++ code. Right? This is not managed C++. It is not the CLR. This is real native code. So, and the hat, for those of you that haven't seen it before, is essentially like a star in normal C++. So it's a pointer type, but it's a pointer to a WinRT object, not a C++ object. So in this method, I'm going to call my platform string to char array, which we'll get to in a minute. This is really just to convert my WinRT string, which is a Unicode string, into an old 8-bit character string used by my code from 1994. And you'll see that I'm using the auto keyword here for the return value, for the return type. And auto is very similar to var in C#. Again, for those of you that haven't touched C++ in a while, what it means is that the compiler will figure out the type of ANSI string for me based on the return value of this function. Right? It does not mean that it's an untyped value or it's a late-bound value. Right? It is a strongly typed value. The compiler will enforce that. It is early bound. But what it means is that I don't need to type in std unique pointer char ANSI string. Right? It's too many characters for me to type. I just type in auto, and the compiler figures it all out. So I use auto a lot. Just like in C#, I use var a lot. Not only is it less typing, but when you refactor your code, it ends up having fewer compiler errors because you haven't put in a type that is now wrong. So I get my string from that text box, convert it to an old-style char star array. I call that getStockTip function. So this is the raw C function here. takes in a char star, it does its thing, and it returns an int, and then I go cast it to that new strongly typed enum so I can return it back to my clients as a nice strongly typed enum, and they get IntelliSense and all that good stuff. Right. So this is really all it took to take that old code back from 1994, that old C code, wrap it up in a nice WinRT library, and have it projected out to C# in a very, very natural way. So let's look now at the platform string to char array function. Now the first thing you'll see here is that it uses a string hat as a parameter, which is a WinRT type, but it returns a std unique pointer of char. And for those of you that don't know what that is, I'll talk about that in a minute as well. And what this is showing is that as long as it's not part of your public surface area, so it's not one of the public things inside your class, you can mix and match WinRT types and C++ types. Right? So I'm taking in a string, a platform string, and returning a unique pointer of char. And our basic recommendation for writing code in C++ in both Windows Phone and Windows Store is that you keep as much of your code in pure C++ as you can, and then you write kind of a wrapper with these WinRT types over the top. The reason being that you want to be dealing in the standard C++ types like arrays or vectors or so on in your C++ code so that you can use all the libraries that you're used to using and you get the performance benefits of that. And then you have this wrapper of WinRT that can project out to different languages, and you end up having to do things like if you have a vector inside your C++ code, you may need to copy that into a WinRT style vector. So there's a bit of an overhead there I mentioned earlier about using native and managed. There can be overheads, which is why performance isn't always the best reason for C++ in a mixed mode app. But within your app, you can mix WinRT types. Sorry, within your code, you can mix WinRT and non-WinRT. And we recommend you move from WinRT to native as soon as you can, do all the processing in pure native C++, and then right at the boundary, project back out to WinRT. So in here, in my function, I'm using string, again, just like it was a star, a pointer in normal C++, I'm using the dereferencing operator here. So again, it's a WinRT type, but it's very natural for me as a C++ developer. I just do the arrow, and I get the methods and properties that I want. I'm using auto again, because I didn't want to type const wchar star. I get the buffer size, again, just using the dereferencing thing. Here I type int, because int is 3 characters and auto is 4, and I'm very, very lazy. But that still works. You can still type ints if you want to. Then I'm going to new up a buffer of chars and assign that to a char star. And remember that I'm newing some stuff up here, because those of you that know C and C++ know that I've now allocated some memory somewhere. And remember that. And then I end up calling ychar to multibyte. Now, this is showing that you can call Win32 APIs on the phone now as well. Now, you can't call all Win32 APIs. There is a subset of them that the Windows Store allows, and Windows Phone allows a very similar subset of APIs. But things like ychar to multibyte and a lot of the file system APIs and so on are available to you. So you can call them now in your Windows Phone applications. And so this is the magic that actually takes it from a wide character array to a single byte character array. And then I return this buffer, this ANSI buffer, wrapped inside this std unique pointer. That gets returned back to stock analysis up here. And I said, remember, I knew up some memory, and I never delete it. Right? And in the past, if you did that, you'd have a memory leak. Right? You allocate some memory, you never delete it, it's just going to keep growing and growing, and you'll run out of memory. But what things like std unique pointer do is actually handle memory management for you. And it's one of the new things in C++. What's essentially happening is when I create this local return value here, it creates a unique pointer, and it knows it's wrapping this buffer, this char star buffer. It then returns it to the calling function up here into ANSI string. And ANSI string now owns that buffer. Right? Ownership passes from the method that I just called back into this method. And then when getRecommendation exits and ANSI string goes out of scope and it's destroyed, it knows that it has to go and delete that buffer. Right? So you now have automatic memory management in C++. But it's not garbage collected, and it's not slow and all that kind of stuff, but it will take care of deleting memory for you when it's no longer needed. And there's a similar concept called a shared pointer, which lets many people reference the same buffer, but it still automatically gets deleted when there are no more consumers. So that's how you go ahead and expose that old C code into Windows Phone. But there's a performance problem I said I wanted to fix, and I want to run the app again just to show you what that is. So if we go here and we type in Apple again, let's say, and I click Get Recommendation, you'll see I can't interact with the app.
Recommendation for is unknown. Recommendation for is unknown.
I spelled it wrong, Apple. But you'll note that I can't click inside this text box.
Recommendation for Apple is hold.
While it's thinking, right? Because my old C code, my old financial stock library, is single-threaded. It runs on a single thread. It does a whole bunch of complex computations, and it's blocking the UI thread. And as you've probably heard at Build, we like fast and fluid UIs, right? We don't want to block the UI based on some background processing. So what I could do is I could go back to the people that own this stock analysis library that's 18 years old or whatever, and say, please go ahead and rewrite that library to be multi-threaded. Right? And they're going to laugh at me because the whole reason we're using this code is because we wrote it a long time ago and it works and no one has to touch it. So I'm not going to do that. And I could say, well, it's the responsibility of the person writing the UI to do this thing on a background thread and manage the UI thread. But that's not a really good solution either, because people just want to write code and get their jobs done, and having to think about that stuff might be a bit too complicated. What I want to do as the owner of the WinRT wrapper is actually make this thing asynchronous, just like the speech is, just like networking and file system are, just like a bunch of other things are in the Windows runtime. And I'm going to show you how to do that in a very, very simple way in our little component. So first things first, let's go to our finance runtime header and go to full screen. And I'm going to copy my existing synchronous blocking API, and I'm going to just paste in another one. And the first thing I'm going to do is I'm going to put async into the name. Now that in and of itself doesn't actually do anything, but there's a programming pattern or a naming pattern in WinRT that anything asynchronous ends in the word async. It's just a hint to the developer that this is something they can await in C#. The next thing I'm going to do is, instead of returning the stock recommendation directly, I'm going to return a WinRT type called iAsync operation of type stock recommendation, and I've put a hat on there because this is a WinRT object, right? So iAsync operation is the magic that turns into the awaitable thing in C#. So now I have my new prototype. Let's go ahead into the code and implement it. First of all, we need to scope it to the class. And we'll have a method body here. Now, the first thing I want to do is I want to reuse the code I already wrote, this get recommendation. I don't want to go ahead and write that again. So I know eventually I'm going to return stock recommendation of stock symbol. But that's still synchronous, so I need to go and make it asynchronous. And the good news is that there is a very, very simple way to do that in C++. It's through this function called createAsync. So I'm going to say return concurrency. It's in the concurrency namespace. createAsync. And I want to return this function inside there. All right. So what createAsync is going to do is it's going to, in a little bit, I'll fix up this error here. It's going to take this get recommendation call, and it's going to make sure it gets run on a thread pool thread, right? And it's going to return immediately so that my UI thread is not blocked, and I can keep my UI fast and fluid. That thread pool will go off and do some work, and then when it's completed, through the magic of iAsync operation and the magic of await in C#, I get a return value and good things will happen. Now, of course, I can't put a function call, a statement with a semicolon inside of the parameters to a function. So what I'm going to do is use a new C++ feature called lambdas. And anyone that's written C# in the last few years has probably used a lambda or an anonymous method. It's basically a way of having code that A, doesn't necessarily have a name, and B, can live inside of an enclosing scope, in this case, inside the scope of this getRecommendationAsync function, and share some of the state like the local variables. And the way that you build a lambda in C++ is very easy. All you have to remember is you have to use every piece of bracket punctuation on the keyboard. So people who are laughing have done this before. So you start off by doing open and close square brackets. Then you open and close round brackets. And then you open and close curly brackets, right? And this is the lambda syntax in C++. And it's probably pretty clear that the curly braces are the function body, or the lambda body. So I'm going to go ahead and put my return value inside there. But it's still giving me an error saying that it can't find stock symbol. Right? An enclosing functional local variable, blah, blah, blah. And the reason is that I haven't told it to capture that variable yet. In C#, the compiler is smart enough. It automatically knows what to capture. You don't need to do that. In C++, you need to tell the compiler what to capture. I'm going to put an equal sign in here, meaning I want it to capture everything. And now if I build, those errors go away. And now what I want to do is, now that I have my asynchronous method, I want to go ahead and hide the non-asynchronous one, because I don't want people calling that. But I'm not going to delete it, because I might have internal reasons for using this blocking method. So now when I build, I will get an error in my C#, because the method I was calling just got hidden. So I'll pop over here, and I'll now say await getRecommendationAsync. Now when I run the application, you'll see that it does this fast and fluid operation where while it's thinking in the background, I can still interact with the UI. So let's go ahead and run this. Let's say Apple.
Heard you say apple.
So now watch, I'm going to click the button and I'll still be able to interact with the text box. So I click here and I can still type in here.
Recommendation for is hold.
And I was too busy typing in here, so it tried to look at this stuff here. But you get the idea, right? Now my code, I didn't change my legacy code. That's still exactly the same. I didn't really change my UI code. I just have to know to put that await keyword in. I did the magic inside my WinRT component to make everything fast and fluid. So now we looked at these things, and we'll look a little bit about calling WinRT from C++ in the next demo. So now I'll talk a little bit about writing portable components. And we know that people want to share code, right? I said portability was the #1 reason we brought C++ to the platform. And with iOS and Android, or other platforms, you can use standard C and C++, you can use common libraries, open source libraries, and of course middleware providers like Unity and so on. And if you're sharing code with Windows 8, you can use all of those things, of course. And you can also use Windows Runtime APIs that are shared between Windows Phone and Windows Desktop. Excuse me. And you can also use the set of Win32 and COM APIs that are enabled for Windows and Windows Phone. And there's a talk here, 3043. You'll have to watch it online because it's already happened. But that's more about managed code portability. So today we're talking about native code portability. But if portability between Windows and Windows Phone is important to you, and it probably should be, then this is a great talk to go look at for more information about code sharing. So now I'm going to do a demo. Up until now, I've been using this very, very trivial stock library. And I said it wasn't to show you how complex the code was, but just to get the concepts across of sharing old code with new code. But now I'm going to use SQLite, which hopefully people have heard of, right? Some hands go up. Yep. So SQLite is a very, very popular open source database library. It's used in a lot of different places. And we're happy that it's now available on Windows Phone. We announced back in June it would be on Windows Phone. And Windows 8 as well. So what I'm going to do is switch over again. And I'm not going to talk a lot about SQLite itself. That's a big topic. I'm just going to show you how easy it is to use it in your applications. So if you already use SQLite, say in an Android or an iOS application, this is how you can bring it to Windows Phone. But I want to start off by showing you my project. Don't worry about this code right now. We'll get to that in a second. But I'm trying to call this SQLite 3 function, standard SQLite 3 function, and it's giving me a compiler error, and that's because I haven't actually made SQLite available to this project yet. Because I wanted to show you how easy it is to do that now in Visual Studio 2012 and Windows Phone. And this part of the demo will probably fail as well due to the same networking issues, but I will show you anyway. Pretend I don't have SQLite on my machine yet. I go to Tools, Extensions and Updates, click Online, and I type in SQLite. Now, if I had a network available to me, it would pop up here in the list, and I would just click on it and click Install. And now SQLite is available to me on this machine. Luckily, I've already installed it, so we don't need to worry about the network. But you can see here I have SQLite for Windows Phone installed. So now how do I make it available to my particular project here? Well, that's really easy too. I right-click on the project and say References. I click Add Reference, and under Windows Phone Extensions, you'll see SQLite for Windows Phone. So I click OK, I click OK, I click Build, and you'll see my error has gone away, right? So that brought in the libs for both ARM and x86. It put the right headers on the include path, all that kind of good stuff. So now I'm ready to bring in my code that uses SQLite, and everything is good. So that's how easy it is to go from 0 to SQLite in Windows Phone. Now, if I run this application, it's a very simple menu application. I won't go into many details about the app itself. That's not really the important bit. But you can see it has things about food items, and I can click on them, and I can get details about them, and so on. And this is obviously stored in a database. And if I look through here, I see that I actually have a bug in my database. My Apple Pie entry isn't showing up a photo for some reason. Right? And the good news is that now that we're using SQLite on the phone, if you have an existing tool chain or an existing way of dealing with SQLite databases, you can now use that for Windows Phone as well. Whereas in the previous releases, we used Link to SQL and SQL CE, and we didn't really have a supported way of creating databases on the desktop. So let's go ahead and look at what's wrong with that. And I'm going to use a standard tool called SQLite 3. And this is a command line tool you can get from the SQLite website. Have people used this before? A few. Basically, you just type in standard SQL statements. So if you don't know SQL, this I won't spend time explaining it. But I'm going to look at the database, and I'm going to update the database. So if I select star from menu items where item name like Apple to see what was wrong with my particular row in that database. We'll see, well, it has an ID and a price and all that kind of stuff, but it looks like something might be missing at the last column. So let's see what's supposed to be there. I know that next to it there was like a chocolate milkshake or something, so I'm looking for chocolate. OK, and we see that the last column is actually supposed to have the name of a JPEG in it. And for some reason, Apple Pie, we lost power. OK, that is really bad. I apologize for that. I won't wait for this to boot up again. It just completely died. What you would see is, using SQLite command line, I would just run an update statement, put in the name of that JPEG, run my app again, and my JPEG is there in the app. Right? So your existing workflow of using tools like the SQLite command line or using visual tools that you might have to create and manipulate and view SQLite databases just works on the phone now because we're using SQLite. The other things I would have shown you in that demo were how to use WinRT asynchronously from C++. Without the code, it's very hard to explain. But I did this talk yesterday, and hopefully that will be online. And so you can look at the yesterday's version of this talk to see about how to do C++ asynchronously, or you can look at it in the documentation. And then the other thing that demo would have shown was within my application itself, I was just issuing real SQL statements. Right? So in the past, when we had link to SQL, it was all based on objects and special attributes and doing magic inside the link library. But now you can just create those raw select statements and update statements and so on, and they all just work because it's real SQLite running on the phone. So that leaves us with the wrap-up. I really apologize about the machine just losing power. It's never a good thing. But the key takeaways today, really three key takeaways from this talk today. The first is that all Windows Phone apps can use C++. Right? I've been showing you demos of mixed mode, and we saw the Direct3D app. C++ enables portability and code reuse. Right? SQLite, my finance library, all those kind of things. And the Windows runtime really is the key to unlocking APIs. It's the key to using our new APIs on the phone, like that speech API, like networking, proximity, in-app purchase, all those kind of things. And it's also the key for you to unlock your own native code and expose that through APIs to C# and VB. And of course, on desktop Windows, JavaScript as well. So that brings us to a slightly early end. Please fill out an evaluation form. They are very useful for us for improving the conference and improving ourselves. So we love the feedback from you for that. And here are some related sessions you might want to take a look at. This is the session for writing native games if you're really into Direct3D. This is the session about networking, Bluetooth, and proximity. This is the code porting talk I talked about, which is really managed code portability. This is a great talk about our new lenses feature, because photography and image processing is one of the key places where we think people will have a mostly managed UI, but then core native libraries for doing image processing, filters, and so on. And then this one, 401, is not a phone-specific talk, but it is a great talk about some of the new things in C++. So with that, thank you very much, and I can take questions if you want to come to one of the microphones. And I'll also be in Building 92 later today if you have more questions. Thank you.
Will we be able to build standard libraries and things like that for the Windows Phone 8?
So the question was, will you be able to build standard libraries? Yes, as I showed in the project dialog, you can build static libs and you can build DLLs as well.
Structured exception handling isn't part of the standard.
And
how is it handled?
My machine isn't there. One of the other things I would have shown you had the machine not died was from C++ outwards, you can throw exceptions, but you throw platform exceptions and they're ref classes. So instead of saying throw foo, you say throw ref new platform exception and then give the string you want to throw.
Yes, but in all my native C++, if I have structured exception handling in there, I probably have to rework that. It's just a guess.
Oh, no, actually, inside your C++, you can still do that, but it can't leak outside to the WinRT world. So as long as you contain it, you're OK to use all the code you used before. But once it gets to that WinRT layer, you'll need to make sure that everything is caught inside, and then you push it out as a WinRT ref exception.
And so I'm assuming, it looks like I've got the full C runtime behind me.
Yep.
Okay.
Yep, C runtime, standard libraries, vectors, arrays, all that kind of stuff.
Hi, do you know if they have a WinRT wrapper for SQLite?
There will be one coming. We don't have one right now. The demo that I didn't show you was my own wrapper, and I'll probably post this on my blog if we don't get the real one out very quickly. But there will be a WinRT wrapper for SQLite available. Yeah.
And if I understand correctly, that can be used on Windows 8 as well.
Yes, yep.
Cool, thanks.
I have a question. What kind of Win32 APIs are available to use from Windows Phone and Windows 8 major apps?
OK. Excuse me. So the complete list is available on MSDN, but kind of a rough survey of what you get in Win32 is you get some of the kind of create file, read file, write file APIs. You get a lot of the IPC-based APIs for synchronization, like locks and mutexes and stuff like that. You get things like load library from package, free library, and on the phone you get WinSock as well. You don't get WinSock on desktop Windows. And you should look at the list on MSDN for the complete list. But there should be enough there to port a lot of existing code.
Okay, so aren't they going to invalidate the certification for Windows 8?
So
Yeah, using Win API,
Oh, yeah.
you can still pass the certification.
Yes, as long as you use the APIs that are on the allowable list, they will go through certification. And there's a tool you can run on your desktop that runs the same certification and tells you if you're using a disallowed API. And also the headers are partitioned such that, for the most part, the APIs you can't use don't appear. Right? So the headers will only give you the APIs that you are allowed to use. But if you happen to just include the prototypes yourself, you could compile it, for example, but then when you try to submit it to the store, they would see that you're calling unauthorized APIs, and then they would reject you.
Do you have any? Do you have any figures of what kind of performance gain you're going to get if you go from managed code to C++? Or if that doesn't exist, give an idea of what does C++ does much better than the managed code.
Okay. Question was, do I have an idea of how much faster C++ is than managed code? Not really. I'm not really a performance expert. But as I was saying before, if you have some existing C# code and it's already running fast enough, especially on the new processors, moving it to native wouldn't be necessary, right? Because if it's already fast enough. And there are some issues with the marshalling back and forth. So, for example, you might think that if I have a large buffer of numbers and I want to crunch those numbers, you might think that, well, C++ is really good at number crunching and dealing with arrays versus managed code, which does around bounds checks on the arrays and so on. So you might think it's easier to take that array, send it down to native, have native do the computation, and then pop it back up again. But unless the computation is really intensive, it actually will be slower because of that copying that goes with the data from managed to native. And the managed code is only slightly slower than native in those cases anyway, right? It's highly optimized. With the compiler in the cloud, right, what gets delivered to the phone is very high quality native code anyway, right? So I can't give you specifics on anything, just to say that it's not automatically faster, especially if there's marshalling involved.
Thanks.
So I just wanted to make sure I understood what I thought you said. So if I have a C# project today and I wanted portability, do I have that?
So if you have a C# project today and you want portability, well, portability to Windows.
iOS?
So iOS and Android don't natively support C#.
That was my guess.
Yeah.
And so that would be the motivation to switch to C++, is to try and get core code portability between the various phone platforms.
Yeah, now that said, they don't natively support C#, but there's a tool chain called Mono, which is actually an open source implementation of the .NET runtime, and that works everywhere. But the thing is, even if your core business logic you get to run everywhere, the UI frameworks are very different, right? So we have XAML. Android uses a Java-based, a similar XML thing for their UI. You use the Objective-C libraries to get UI on iOS. So the UI layer is never really portable.
Absolutely.
But the core code, C++ is the most portable. C++ is the most portable. You can port C# if you use the Mono toolchain, but typically you'll have better experience with portability with C++.
And I'm assuming that those portions of my code that are Win32 would not be portable.
Correct. So the way that people tend to deal with that is they end up writing a platform abstraction layer or a platform abstraction layer where they define their interface of the things they need, like open a file, create a thread, and then there's a thin layer that there's an Android version, an iOS version, and a phone version.
Thank you.
You're welcome. Over here?
Hey, good morning. So if I understand correctly, this is a direct segue for what you just said, and this is the way we've been doing it on iOS and Android and like desktop platforms. So we do have like a core library that we use, all C++. That's the way to go. Is that the takeaway from today? That's my first question. So do as much as possible and then write this like user visible glue, whatever you want to call it later, right?
Correct, and that's, I mean, even before Windows Phone and Windows Desktop, if you were just going between iOS and Android, right, that was the best way to do it, right? Have as much code as you can that's just pure standards-based C++, and then you have an abstraction layer for things like file system and so on that might be different, and then you write your different UIs, your iOS UI and your Android UI. And now we're just saying, well, if you've done that, you take that same core, you replumb the bottom with Windows-specific APIs, and you plumb the top with DirectX or with XAML, and you've got the best portability scenario there.
And follow up, so and between Windows 8 and Windows Phone 8, what would be the best choice for us to do so we don't have to do a lot of, or if any, changes in that shim layer?
So in Windows Phone and Windows 8, did I say that right? Yes, Windows Phone and Windows 8, using the shared WinRT surface area is probably your best bet, and that will give you access to files, access to networking, sockets, etc., in-app purchase, threading, other things I'm forgetting right now. But if you use the WinRT APIs that are common between Windows Phone and Windows Desktop, that'll be very, very portable.
Excellent. And completely different question, and I'm sure a lot of people will run into it, and still haven't gone through running the tool through our lib. There's a lot of people using open source projects aside from SQLite. I don't know if you're in a position to, if you've seen this, if people have come to like from big projects like Boost or you name it, OpenSSL and things like that, to come back and say, hey, this doesn't work.
Yeah, so
it doesn't work, doesn't pass the cert kit.
I don't know of anything like that myself. Okay. I imagine that because of the nature of the open source projects, people will do that, but I don't know anything right now.
Okay, thank you.
You're welcome. Anyone else? Okay, thank you, everybody.